Hey guys, and welcome to Functional Print Friday. I got another problem I want to solve. You could probably guess what it is already just by the shininess here on my workbench. These are the oil cans that I typically use on my lathe. One of them, actually two of them, are whey oil. Whey oil is the stuff that you put on the slideways of the lathe, and this one is cutting oil. The reason there is two different ones for whey oil is because, well, actually, I guess I don't really need two. I really just need this one. I tried to buy two of these brown ones at first because they're great. Reviews on them are great. I've never had leaks from either one. Unfortunately, the tip on the spout is just too big for the oilers on this lathe. All these little shiny brass things you see with a ball, they're ball oilers. The oil can pushes the ball down. There's a spring underneath the ball, and then it pushes oil into that to lubricate all of the slideways on the lathe. The ways here and all of the slideways for all of the other surfaces that move on the machine. So from the same brand, Goldenrod, I purchased this can that has a smaller end on it, and it works great. It pumps oil into all of those ball oilers, but it leaks. And I even sent it back and got another one. I figured it must be defective because these brown ones are great. But the second one did the exact same thing. And I'm actually just noticing here on the screen, I can see a shiny spot. Yeah, I can see a shiny spot here. This is not the first time I've cleaned this up. This is probably the third time I've cleaned this up. Last time there was so much oil that had leaked out, it ran down off of this and was going down my workbench. And it drips from the spout. I think it leaks from the can itself too. I haven't quite figured out where yet, but there's always a puddle here. And I pick it up and then I get drops. It drips on my shoe, wherever. And now I see there's oil on the bottom of this one too. That's not from this can. That's the oil dripping from this one that's collected here and now has wicked underneath this one. It's probably, it's great. It's my anchor loop too. So I want to come up with a better solution for this. My first solution was to just put this piece of metal here so that I wasn't getting the oil absorbing into the wood of my workbench, but clearly that's not working because it runs off of that and there's still a whole bunch of oil on the bottom of the cans when I pick them up. I dug through my stuff over here in the shop and I have this aluminum pan. Looks like it says always use broil cover. So this is probably out of like a toaster oven or a convection oven or something. I think I at some point bought stuff from an estate sale that was just, I bought the whole tray of stuff. So I guess I got the tray for free. So this will partly solve the problem if I put it over here and set the oil cans in this, but it won't solve the problem of the oil getting on the other cans and or always being on the bottom of this one, because this is the leaky one. I don't even want to touch it, but if I pick this up, the bottom of it is covered, so oil is going to drip off of here as I go around and try and oil the parts on the lathe. So what I want to do is put a grid in here, a raised grid, so that the oil can collect in the bottom of this pan, but none of the oil cans are ending up with oil on the bottom of them. And I have some other oil cans I can move over here too. I've got a couple other ones that also leak. They just leak really slow. So obviously we could model this grid, and I've done that before. I've modeled grids. I made some for my wife for the garden last year to put underneath tomato plants to keep the tomatoes off of the ground. And it's tedious to model that. Maybe there's an easier way with like a plug-in for something. And when I say grid, if you guys are not following, just like imagine a whole bunch of slats of plastic running this way and then a bunch of slats intersecting them running this way, and it's raised up. I have an idea for how I think we can get there and still have it be a strong grid without any 3D modeling at all. All right, I've opened up orcaslicer. That's the slicer that I'm going to be using for this today, and it is the slicer that I normally use. However, everything that we're going to fool around with today, you should have available to you in other slicers. The settings just might be in different places or on other tabs, or you might even need to turn on advanced mode to get some of them. Now, all that said, I don't expect that we're going to change anything really far outside of the norm here. So you should be able to apply this to really any slicer. All right, so I've got my Neptune 4 Max selected because we know that this is going to be, I think it was 11.5 inches in one direction. So this is the only printer I have that's going to do something that big. Now, you notice I have no model on the plate. There's actually nothing to design here in CAD outside of the slicer. We can do it all right in here. So I'm going to go to Add Primitive, and I'm going to just do Cube. Now that starts us off with just, I think it looks like a 42 by 42 by 42 cube. That's not particularly valuable, but we can change the size of that right here in the slicer. So if I go to scale, let's see, I think 11.5 inches is about 292 millimeters. Oh, and make sure you have uniform scale unchecked because we want to edit all these settings individually. Our other direction was 8.5. That's going to be about 216 millimeters. And we certainly don't need this thing to be 42 millimeters high. I'm thinking 12 is probably high enough. Oh, and I learned this the hard way. You have to hit enter when you edit that number. If you don't, click and change another number. So see if I make this 12 and then I just click off, it doesn't do anything. So you either have to edit the number and then click in another field for it to accept the change, or edit the number, so I'll change it to 1, hit enter before you click out. So, all right, change that back to 12, hit enter. Okay, now we have a solid cube here that represents the size of the grid insert that we want for that tray. So there's gonna be a number of things that we're gonna have to change here. The good news is, I don't see any reason why you can't just save these as a preset and then pull it up again when you want to do this type of model. So I'm going to turn wall loops to 0. I'm going to set top shell layers to 0. Guess actually I could just type this in, it's quicker. Bottom shell layers I'm going to also set to 0. I'm going to set my sparse infill density to 10%. Now this is where you're going to have sort of the control over how tight of a grid you want for this. I find that 10% is good for just lining the bottom of something that I want to set things on that might be oily or might have just some grit on the bottom of them. But you can adjust this anywhere you want. And when we get to the point here where we're getting a preview, I'll show you what I mean by that. We're also going to turn all this other stuff in here off. So sparse infill anchor length, I'm just going to set everything in here to 0. Maximum length of infill anchor, no, I don't want any of this. We're just going to turn this to 0. Let's see, sparse infill threshold, yeah, 0. I'm just going to set everything to 0. I'm going to leave infill combination off, and I'm going to turn off this detect narrow internal solid infill. So basically we're just setting it to the most standard infill that we can. We don't want it to do anything extra. So let's go ahead, let's hit slice plate and just see what that looks like. All right, so you can see we're already kind of getting close to what we want, right? We don't have a top, we don't have a bottom, we don't have any walls, but there is some problems with this. It's going to be really weak here on the edges because it just comes out into these unconnected shapes. And in fact, we've even got some sections that are just floating here on the edges. So that's not going to work, but we can fix that. So over here where it says infill direction, I'm going to take this 45 and I'm just going to set it to 90. Okay, there we go. That looks a lot better. We still have, we're going to naturally have to end here in some sort of open sections, but this looks like it's going to be a lot less fragile than what it was trying to slice before. Now the skirt is not doing us any good, or actually I think we have a skirt and a brim there. So let's go turn those off. See, skirt loops, 0, brim, no brim. Slice it again. All right, that is starting to look a lot better. Now, the challenge here is I already know just from working with, failed prints or other things that I've printed with no infill, that grid infill printed like this, it's not very strong. I could crush this. We could print this right now and I could probably crush this just with my thumbs, just pushing down on it, because it's only one extrusion width wide. And by default, the sparse infill ends up getting squashed out a little bit further. Here, I'll show you what I mean. Let's go over to quality. So line width sparse infill is at 0.45, even though on this profile, our default line width is 0.4. So let's take the sparse infill and set it to 0.42. Now that's not immediately going to make a change here. In fact, I don't think we're going to see any change at all. If anything, this might look a little bit thinner. It's probably a little bit stronger because we're not sort of just pushing the filament out in an unconstrained fashion, because the hole on the nozzle is only 0.4. But it's going to be important for something that we're about to do to make this a whole lot stronger. So we go to prepare. Now we know we've got this cube here, right? Well, I'm going to take this cube and I'm going to clone it. I'll make one copy. Now, annoyingly, orcaslicer just positions the cube, I don't know, X degrees or some set value away from the cube that we already have. So the first thing we have to do is let's look at the position of this cube. Let's make this a whole number. So 208, oops, 208, and then 216. Remembering to hit enter after you type that number in. The Z we can leave alone. That does not matter for what we're doing. Now I'm going to click on our other cube. And let's see, this was 208 and 216. I'm going to take our other cube and I'm going to position it in the same spot. Okay, so if I slice it, we're not going to see any difference at all right now, but we're already starting to get horrible, serious warnings here from our slicer, because what this is going to result in is trying to make the exact same sparse infill as the existing cube. So, and some of you may already see this coming, but what we're going to do next is go back to prepare. We're going to take one of our cubes and we're going to move it by 0.42. Now when we slice this, take a look at that. Now our sparse infill essentially forms the same as two outer walls. I can already hear you guys down in the comments telling me that the nozzle is going to rub on the top of this, and yeah, it probably is, but I don't think it's going to be a big deal, or I should say I don't think it's going to be any more of a big deal than it is just printing a single wall of sparse infill. Boy, that statement really sounds confusing, but kind of what this looks like to me really is outer walls now versus sparse infill. But let's look at the preview here. So this is the preview of the top layer. So what we're seeing right here is actually all of the layers underneath the top layer. And if I drag this across, we see it is drawing all of the, we'll call it the vertical lines here first. Then it's going to draw one horizontal line across. So this would be exactly the same as normal sparse infill, normal grid sparse infill in a model. And yes, these are going to intersect. There's no space here. The nozzle is not going to stop extruding. It's going to go right over this line, and some of that filament is going to squeeze out. And you might actually hear the nozzle contacting that as well. That's why grid infill, you already have sort of by default set up a little bit of a conflicting path on the infill. And if you're over extruding at all, it can get to be additive and your nozzle can actually start to hit the infill too hard and cause issues. But if we keep going across here, okay, we see it does a second horizontal line, all right next to the first one, also crossing that one line. And then finally, we have our last vertical line. Now this is the one, if we're gonna be worried about anything, this is the one that I'm kind of worried about, because now we're asking the printer to continuously extrude, but yet now cross two paths in a row of, well, sparse infill or outer wall, pseudo outer wall. So that's kind of the thing that I'm not 100% sure is gonna work, but I think we're just gonna have to send it and see what happens, because the preview of this certainly looks like what I want. And while we did kind of a bunch of work to get here by tweaking all of these settings, again, I can just save this at this point as, you know, a preview. And if I wanted to do this again, the only work that I'm going to have to repeat is the process of creating the size cube that I want for, you know, this grid insert, and then cloning that cube and just moving it the width of our infill extrusion. All right, so I'm going to do that. I'm going to save this as a preset. Let's save this as FPF 0.2 millimeter grid only. All right, I'm going to go hit print, and I think we're going to be keeping a pretty close eye on this because I don't know what to expect. I mean, full disclosure, I messed around here in the slicer to see if I could even, you know, do this before I started shooting, but I have not hit print and tried this yet. So, all right, let's do it. Hey guys, I'm sitting here editing this video and I just checked the subscriber count and it's over 10,000 subscribers. And I just wanted to say thank you to you guys. I knew it was getting kind of close, but I didn't think it was that close. There's been a lot of interest in the last couple of videos that were put out, which has been great. So thank you to all the new subscribers, and thanks especially to the guys that have been hanging out here on the channel for a long time. You can see here with the channel growth chart, I mean, this channel had pretty slow growth for a long time and then really started to pick up, and I'm just amazed. I never thought this channel would have this many subscribers. I know 10,000 is not a huge amount relative to a lot of other channels, but it's more than I ever thought this channel would get. So thank you again so much, and I'll figure out in the next week or two, you know, some sort of giveaway or something to do just as a thank you to you guys. So stay tuned. That'll show up on either the community tab in the channel, or maybe I'll just drop a quick video on it. But guys, thanks again. Let's get back to the video. All right, while it's printing on the Neptune 4 Max, let's try some smaller ones with some different settings just to see what things look like on one of my other printers. All right, I stopped the print on the Neptune 4 Max. It hadn't even actually started yet, but based on the result that I was seeing on the A1, I think we have a problem, but I think I might have a solution to it. So if you remember before, I had said turn off infill combination. And what led me to say that was I looked at this, and the model printing time without combining the infill is 3 hours and 21 minutes. It's printing 60 unique layers, and it's printing that sparse infill pretty darn quick. Now, if you turn on infill combination, it's going to slow the infill down a little bit, but it's only going to have to print 30 layers of infill. If you're not familiar, what infill combination does is it takes whatever the layer height is, in this case 0.2 millimeters, and it skips the infill for every other layer. So normally if we had outer walls on this and, you know, top and bottom layers, it would print the outer walls for each layer, but it would only print the infill once every other layer, and it would do it at twice the normal height. If we slice this with infill combination on, we don't reduce the model printing time by that much. It goes from 3 hours and some odd minutes to 2 hours and 49 minutes. So pretty close. I mean, we're only talking about like maybe a 20-minute difference. But now we're only printing 31 layers instead of 60. And we're not going to have gaps here because it's actually going to print those layers at 0.4 millimeters. So I looked at this and I thought, well, geez, for the extra 20 minutes, I'm probably going to have better layer adhesion if I print every single layer. But now what I'm thinking is maybe we do the infill combination, because now we're going to have 0.4 millimeters underneath that nozzle. So we're going to have a lot more room for the filament to flow around at these intersecting points. So let's try that. And we'll try it on the A1 first, but because this Neptune 4 Max again takes so darn long to actually start printing anything, I'm going to send the job to this one first with that tweak, and then we'll go and we'll test that on the A1. So, all right, I'll bring you guys back. All right, our test prints all came off of the Bamboo Labs A1 just fine. Still no fires from that machine yet. And this is the 15%, this is the 20%, and this is 30% over here. And 30% is honestly probably too dense for any application. I can't think of what I would really use this for. I guess if I had a bunch of sand and stuff mixed together, the sand would probably go through this and not the parts I was trying to sort. But these other ones are probably much more useful for sorting, or for, you know, just in the bottom of a parts tray to keep like the grit and stuff out. Actually, this one, I may, since we could really do this with any shape, I mean, I used 2 cubes, but we could use, you know, 2 circular objects as well. Let me grab my parts tray, I'll show you what I mean. Here's what I'm talking about. So this is one of the parts trays from my little rolling workbench thing. And if one of these fit in the bottom of this perfectly, that stuff couldn't get to the sides, I could see just leaving this in here, because what happens is I'm taking something apart and, you know, I'm throwing pieces in here. Oftentimes the bolts are rusty, and then I go to dump everything out, and it's like a mix of bolts, nuts, and rust and other dirt or paint that's come off them. If I had this in here and had this maybe, I don't know, thicker than this, I did this one at the, I think this one is 5 millimeters. These ones I did 2.5. But if I did this one at maybe 10 millimeters and it fit nicely down here in the bottom, I could see how that would make it a lot easier to get stuff out of here without picking up the grit and junk from the bottom. So these are all done in grid, as I mentioned, which means the printer does intersect these lines, and it wasn't anywhere near as bad as the test print that I stopped by doing the combined infill, because there's always almost 1/2 millimeter underneath the nozzle when it's laying down the material. I tried two in rectilinear because rectilinear doesn't have that problem. The thing with the rectilinear is, because it doesn't have that problem, it is also not really bonded together. Like, I can separate this pretty easily with just a fingernail in the end. So yeah, I wouldn't say this is really viable, but I did want to try it, and I figured somebody would probably suggest it in the comments if I didn't give it a try. So yeah, rectilinear just doesn't work out. Here is rectilinear in the same spacing as our hopeful piece that's going to go in the tray, and you can see the mess that this is. I mean, it didn't even really stick together while it was printing. Now, of course, there's no collision with the nozzle on the surface, but that doesn't really work out so hot. All right, I think there's about an hour left on the big one for our tray, so I'll bring you guys back. All right, guys, it is done, and it came out really nice. No issues whatsoever. I mean, there's some mess here on the edges just because I don't think it's retracting the filament, since, it's just doing infill. We could probably turn that on. I think there's a setting for either reduce or turn off retraction for the infill, but I mean, unless you're using these edges for something, it doesn't really matter. It's bonded really well. The first thing I did was just take it like this and flex it back and forth to see if I could hear any creaking or things separating, and I can't. It's printed very much the same as you would expect from just a print with two outer walls. And I don't know if the camera's picking it up, that the extra thickness here. I mean, at some point in time, we've probably all tried printing just the infill on a print, and it kind of works. It's just really, really flimsy. But by doing that offset of the width of the layer the width of the extrusion width in both the X and the Y, it really strengthens it up. Like, this is, I mean, I would stand on this. Yeah, nothing. And I'm standing on just one foot. My other foot's in the air. No issue at all. This sucker is strong. All right, let's see how it fits our tray. You know what? I didn't think about the rounded corners on the inside. It's actually, it's a little bit big because of those rounded corners. We could probably just trim that. Yeah, that fits perfect now. All right, let's clean up this mess over here and get everything in place on this. All right, that looks pretty good. The only problem is the bottom of this thing is not flat, so I'm gonna have to straighten out the bottom of this this thin aluminum pan so it doesn't wobble around, because that's gonna drive me nuts. But otherwise, I think that worked out pretty well. I guess actually it probably makes more sense to have them this way. I just want to make sure the end of that one is still over the tray, and it is. There we go. Probably a little bit easier to grab since I'm usually standing over here on this side. So guys, let me know down in the comments below what other ideas you have for this little hack, and let me know if you've seen anyone else do this. I've seen plenty of examples of folks just printing the infill of solid objects, or printing it with the outer walls and printing it with a solid bottom, but leaving the top off so they can just get an idea of what different densities of infills look like. But I haven't seen anyone that has done that trick of having two solid objects, offsetting them in the X and the Y by your line width so that you get essentially double thick infill. And this is tough. This is nothing like the infill that, if you've ever had like a failed print that you've pulled off the bed and pushed on the infill, if it's grid infill, Unless it's really, really dense, you can pretty much just collapse it with your thumb, and this is quite strong. In fact, yeah, I can break it apart if I try real hard, but you can see that's bonded really nicely. All right, guys, as always, thanks for hanging out in the shop with me for this week's video. I've been doing 3D prints on a weekly basis, several a week, for a long time, and long before I started this YouTube channel. And it's really nice to be able to share it with other folks that are interested in this type of stuff. Again, I really appreciate the comments that you guys leave me. And if you got anything out of today's video, take a second, hit the like button. It really helps out the channel. It doesn't cost you anything except half a second to go click it. And if this is your first time on the channel by chance, we do a new functional print every single week. So check out some of the other videos. If you're into that, hit that subscribe button. And guys, if you do, I'll see you next Friday.